So today's method for solving a system of linear equations is actually goes by two names. We could call it the linear combination method, or at other times we might call it the elimination method. You need to know both. Both names help us remember something important, which I do want to make sure we're writing down right now. So the first really important thing is the word combination. Obviously comes from the word combine. And in math, there's two ways we can combine things. Combine either means add or subtract. In math, the word elimination is also really important. Eliminate means get rid of something. So the name linear combination actually is very descriptive of what we're going to do. So what we're looking at here is, again, we're just putting into context, the linear combination or the elimination method is just another method for solving. We've already talked about graphing, we've already talked about substitution. Now what's important here is the goal for substitution, what we've written down on other note packets, which I've recopied here, is with substitution the goal was to rewrite the system that was usually had more than one variable, like x's and y's. Using substitution, we were going to rewrite it so it only used a single variable, like just x or just y. So if it was just an x or just a y, we could get that value of the variable by hand. The linear combination method does the same exact thing. So combine, right? So combine means use addition or subtraction. So we're going to combine two equations to eliminate one of the variables. So that's why it's called the linear combination method, also called the elimination method, because again, the word combine is going to tell us that we're going to combine two equations, and then the reason we're combining them is to eliminate one of the variables. So again, our goal is the same with substitution. We're just going to do it in a different method. We want to start with two variables, rewrite it so there's only one. Now, one thing we need to do before we really get into elimination and solving systems is we need to kind of just remind ourselves of a math fact. Addition and subtraction works in multiple directions. So what I mean by that is if I start with something like, let me rewrite that, 4 plus 3, we know that that is clearly equal to 7. Let's say I write something below that, like 3 minus 6. Let's do plus 6. We clearly know that that's 9. What I want you to see is, what I'm saying is subtraction and addition work in multiple directions. So in other words, what I'm seeing is if I go to the right, if I go this way, right, 4 plus 3 is equal to 7. If I read left to right, 3 plus 6 is definitely equal to 9. So again, I'm just showing I'm reading it that way. But I can also read it in the other direction. What if I read it up and down? Well, 4 plus 3 is equal to 7. 3 plus 6 is equal to 9. And then on this side, 7 plus 9 is equal to 16. But if I go back and read it left to right, that also works, right? 7 plus 9 is 16. What we're seeing here is if we have a bunch of addition and subtraction, like 4 plus 3 and 3 plus 6, I can add left to right, or I can also add up and down. It works for subtraction too, and it works for things that are more complicated than just numbers. So let's say we had 4x minus 3y. Sorry, let's rewrite that as 4x minus 3x. I know that's clearly x. I can come up with another thing like negative 3x plus 7x. Well, that's clearly positive 4x. So again, I can read them left to right, but I can also add them. Let's say I want to add these things together. I can add them up and down. So 4x minus 3x is 1x. Negative 3x plus 7x is a positive 4x. X plus 4x is equal to 5x. So again, 1x plus 4x is equal to 5x. So we're seeing this connection between adding and subtracting, not only left and right, but also up and down. This is just a background skill that we're going to use to combine equations. Now that we know that background skill, let's go back to the overall idea of linear combination. So what I've copied over here is our goal. So the goal was just like substitution. So what we can see in this substitution on the left side, we have an x variable here, and then both equations also have a y variable in them. So what we did was we were saying, well, we can't solve for both of those variables at once. So using the substitution method, what we did was wherever we saw this y, we replaced it with what y is equal to. It's 2x plus 6. So instead of 3x plus y is equal to 16, I know that wherever I see y, I can replace it with 2x plus 6. So then we went ahead and instead of y, we replaced it with what y is equivalent to, which is 2x plus 6. So now, after that substitution, this equation only has one variable. And that's really good, because if our equation only has one variable, we can solve it. So 3x and 2x is 5x, plus 6 should equal 16. So I get 5x is equal to 10, so in other words, x is equal to 2. And again, then we'd have to go solve and get y, and if we did that, we would then be able to see that y was equal to 10. But again, the main idea here that we're trying to get at is that we started with two variables in both equations, x's and y's, and we used a method to rewrite one single equation that only had one variable. The linear combination is the same exact idea. We just do a different process to get there. So what I notice in both of these equations is that they do have two variables. There's an x somewhere in both of them, and in both of them there is a y. Now, aside from using the substitution method, how can we use this other method? Well, the goal is to combine these two equations. So when we see the word combine, we know combine means add or subtract. So in this case, what I'm going to do in this little box over here, I'm going to indicate that let's add these together. So if I add these, so in other words, we're adding up and down now. So 3x plus 2x, well, that's 5x. What's really nice here now is if I try to do y plus negative y, that gives me 0 y's. On the right side, 16 plus negative 6 is a positive 10. Now what's nice about this is 0y, that's just nothing. So I'm going to get rid of it. I'm just going to rewrite the equation. 5x is equal to 10. So using elimination, or in other words, the linear combination method, we were able to start with a system that had x's and y's in it. By combining them using addition, we rewrote it. So now our new equation down here only has one variable. So then we can see that x would be equal to 2. We'd go back and find y. And in this case, we actually do get y as 10 again. But the idea here is that we're trying to draw parallels. We start rewriting a system that has more than one variable. So the system originally had more than one variable here, and this system had more than one variable. Whether we use substitution or elimination, we want to somehow rewrite a new equation that only has one variable. So on this side we use substitution, on this side we use the idea of linear combination. But what we can see is in the second step, after we do one of those things, we're always left with an equation that only has one variable. So that's our overall goal with elimination. So this is a list of steps that will allow us to use elimination. So I would take a moment just to kind of copy them down. And then what we're going to do is we're going to use them on the next couple of examples. So the main idea is what we want to do something with elimination, we want to have the equations set up in a way that at least one pair of coefficients is ready to be eliminated. Meaning, like, if I add or subtract, they'll go away. So I'm just going to add that here. So if they're ready to be eliminated, if I add or subtract them, they go away. Now, once I see that there are going to be two variables that would kind of go away if I add or subtract them, I want to actually combine them. And the way that I combine the equations is I use addition or subtraction. I want to use whatever operation would actually cause those variables to go away. So after I do that, I should be able to have an equation in one variable, which I'm going to solve. And that's going to give me the answer of that one variable. Once I have the answer to that one variable, I'm going to substitute that back in to find the other variable. And then as always, we do want to check. So let's do our first example. So I've copied the steps that you wrote down already, and let's look right here. So this is our system. So the first thing to do would be, we got to look at it to see if it's ready for elimination. So we're looking for at least one pair of coefficients that's ready to be eliminated. So for example, what I notice is negative 2x's and positive 2x's. Those are ready to be eliminated. Because what I'm saying on step 2, if I were to combine them in either addition or subtraction, I want to get the coefficient to be 0. So what I would see here is if I were to simply, and I always want you to draw this box so you can indicate to me what operation you're doing, but do I want to add or subtract these equations? How do I want to combine them? Well, as we said over here, we want to combine them in a way that would make the x's go away. So a negative 2 and a positive 2, in order for those to go away, I have to add them. So what I now know I'm doing is I'm adding these two equations, so I'm combining them with addition, up and down. So negative 2x plus 2x is 0 x's. Now I'm going to do addition up and down, so negative 3y plus, sorry, that was positive 3y plus negative 5y. So if I add those together, I get negative 2y. And then at the end, I would have to add 4 plus negative 8, and that gives me negative 4. So here we check. 0 x's, that's just nothing. So I'm left with negative 2y is equal to negative 4. What we want to do then is, if we combine them correctly over here in our list of steps, what we should see is we should solve that equation, and it should only have one variable left. And it does. So this is our step 3. Let's find out what y is. So I'm going to divide both sides by negative 2. So I get y is equal to 2. So once I know what y is, the directions tell me to substitute that value. So we just found one variable, so substitute the value of the first variable into the other one to find the remaining. So it says into one of the original equations. It doesn't matter which one I do, I'm just going to choose the first one because I so chose to do that. So I'd plug in the y value that I know, and I'm trying to find x. But again, what we notice, if I start here with the first equation, negative 2x plus 3y is equal to 4, there's two variables there, and I can't solve for two variables, so I'm going to use substitution to change y to the number 2. After I use substitution to change y to the number 2, I now have an equation that's only in one variable. So we get negative 2x is equal to negative 2, so x is equal to 1. So I found the solution 1, 2. Now, as always, we do need to check our answer to make sure it's correct. So I've actually prepared that a little bit earlier just to save some time for me, so you can go ahead and look at that solution, which I've included right there. So we do see that it does satisfy the first equation, and it does satisfy the second equation. Now the second problem is super important because it helps us address the first question. So the first step. What we're looking for is at least one pair of coefficients, right? The numbers in front of the x's or the y's that are ready to be eliminated. What I notice here for the x's, there's a 3 and there's a 6. If I add them, they're not going to go away. If I subtract them, they're not going to go away. When I look at the y's, 2 and 5, if I add them, they're not going to go away. And if I subtract them, they're not going to go away. So that's the main idea here. So simply combining these equations, right, just using addition or subtraction doesn't eliminate a variable. So that's what step number 1 is telling us. We might need to rewrite. So in this case, we need to rewrite. So what it tells us to do is multiplying one of those equations. I'm going to highlight that in red here. So multiplying by a constant is usually the easiest way to rewrite one of them. So what I'm looking for is I want the equations to go away. Like I want 6 and 6. If I subtract 6, they would go away. So what I could do is I could multiply. Write that here. So how am I going to rewrite? I'm going to multiply equation number 1, so that first one, by 2. Now, I'm just going to rewrite the equation first. So here's 3x plus 2y is equal to negative 2. So what I'm going to do is I'm going to multiply everything by 2. So everything on every side. So 2 times 3x turns into a 6x. 2 times 2y turns into a 4y. And on the right side, 2 times negative 2 turns into a negative 4. Now, why did I want to do that? If I go ahead and copy the original second equation, so this equation I'm just going to bring down, 6x plus 5y was equal to negative 2. After I rewrote that, I can clearly see that 6x's and 6x's could be eliminated from each other. Now, how would I eliminate them? What I would do is I would subtract these two equations. And again, subtraction is the operation I do for all of them. So if I took 6x, we'll do it in blue first. If I took 6x and then I subtracted 6x, that's 0 x's. On this y's, I'd have 4y, and then the operation here is subtracting. So 4y minus 5y, that's negative 1y. On the right side, negative 4, and again the operation that I'm using to combine is a minus. So negative 4 minus negative 2, I'm going to write that out. So I can do the change, well that's negative 2 itself. So again, I can see I did it right because 0 x's would go away. And I'm just left with this. Negative 1y is equal to negative 2. So when I combined those equations, I did get a coefficient to go away because it's the coefficient was 0. So I can solve that equation for the one variable that's left. So I divide by negative 1, and I get y is equal to 2. Once I know what y is, I'm going to plug it back into one of the originals. I'm just going to choose the first one on this one, and I can find x. So 3y plus 2 times y should equal negative 2. So I get 3x plus 4 is equal to negative 2. So then 3x is equal to negative 6, which tells me that x is equal to negative 2. So the solution that I found is the point negative 2, 2. So just quickly, what I've shown on the left side here is our answer, negative 2, 2, is the answer. I plugged this point, x and y, into the first one, and it satisfied the first equation. And when I plugged the x and the y into the second equation, it did satisfy the second equation. Now, what's kind of important about the last example here, though, is I want to do this problem again. So I'm just going to go ahead and rewrite the original system of equations. So we're working with 3x plus 2y is equal to negative 2. And we're also working with 6x plus 5y is equal to negative 2. And we did it the first time, we eliminated x. It doesn't matter what variable you want to eliminate. So for this one, let's try to eliminate y this time. Because again, it doesn't matter which we eliminate. And the reason I want to eliminate y on this one is in the directions, when we rewrite them by multiplying by a constant, we might need to do it to both of them. So for instance, if I wanted to cancel the y's, I don't think there's anything I can multiply 2 by that would make it cancel out with a 5. Like the multiples of 2 are 2, 4, 6, 8, 10, 12. That doesn't cancel with a 5. Same thing down here. If I looked at this 5, I don't think there's anything I can multiply that by to get it to cancel with a 2. So what we're saying is we might need to rewrite both of them. So to show you how to rewrite both of them, let's say I wanted to eliminate y. I'm going to multiply the first equation by 5. So I'm just going to call that equation number 1 by 5. So everything is going to get 5 times bigger. So that new equation would be 15x plus 10y was equal to negative 10. And maybe for the second equation, let's multiply equation number 2 by 2. So everything in this second equation is going to get doubled. When I do that, I would turn into 12x plus 10y equals negative 4. After I've rewritten both of them, I'm just going to rewrite them in black on top of each other. What I can see now is that when I combine them, the y values would be ready to be eliminated, because if I have 10y and 10y, if I were to subtract these two equations, they would go away, right? 15x minus 12x is 3x. 10y minus 10y is no y's. And over here it might help to write negative 10 minus negative 4. Well, that's negative 6. So again, I've eliminated y, so there's just an x. And what we'd see is that we will get the same exact answer no matter what we choose to eliminate. So I'm not going to finish it all the way out, but you might need to multiply both equations depending on what variable you're trying to eliminate.